Hey guys, so in this video today I'm going to be teaching how to solve for the empirical formula of a compound. So in this video I'm not really going to be talking about what an empirical formula is. This is just going to be very straight to the point, what numbers do I need to plug in to get an answer kind of video. Now if you want me to go more in depth on what an empirical formula is, just give this video a thumbs up and I will probably do that video in the near future. I just want to have a video available that just teaches you how to plug in numbers and get to your solution, because I know that's what a lot of people kind of get messed up on because there's a lot of steps. So we're just going to be taking a look at this problem and learning how to solve. So first let's take a look at our problem. Find the empirical formula of a compound that is 48.38% carbon, 8.12% hydrogen, and 53.5% oxygen by mass. So the first step is very simple. We're simply going to be taking the percentages of each element and dividing it by their molar mass. If you don't know what the molar mass is of an element, it's basically this little number right here under each element. This is also known as the atomic mass. So for example, the element hydrogen has a molar mass of 1.008. The molar mass of rubidium is 85.47, so on and so forth. So let's take a look at carbon first. It's got a percentage of 48.38. So we're just going to take 48.38 over 1 and divide that by its molar mass. And I just put the ones here for a conversion factor, but if you just wanted to write 48.38 over the molar mass, that's fine too. The molar mass of carbon, if we look here, is 12.01. So we have 48.38 divided by 12.01, and that's our simple equation. So we're just going to put that in our calculator and divide 48.38 divided by 12.01. Now that gives us a nice long answer, so we're going to round it to the accurate number of significant figures to make this number a bit easier to work with. So as we can tell, this number has 4 sig figs and this number has 4 sig figs. So let's make this decimal. So it has 4 significant figures. So we have 4.028. That'll be our 4 significant figures. And since this number is below 5, we don't need to round up to 4.029. So simply our answer for carbon is 4.028. But we're not quite done yet. So next let's take a look at hydrogen. 8.12% over 1 for a conversion factor. Excuse the fact that my grandpa has this TV on in the other room. Can't tell if you can hear or not, but if you can, I'm sorry. So our molar mass of hydrogen is 1.008. So we're going to divide 8.12 by 1.008. And that gives us a nice long decimal once again, so we'll shorten that up a bit. Oh, totally just gave me 3 numbers, but that's okay. So if we look here, 1.008 has 4 significant figures, and 8.12 has only 3. So if you've learned about significant figures yet, when you're multiplying or dividing numbers in chemistry, you always want to write your answer in the least number of sig figs. So our least number of sig figs is obviously 3. So if this is our decimal, we'll simply write that as 8.06. Since this number is 5 or higher, we're going to round up. So our answer right here is 8.06. Now let's take a look at oxygen. 53.5 over 1 is our conversion factor. If we take a look at the molar mass, if we take a look at our molar mass of oxygen, it is 16.00. And once again, you always want to make sure that you're writing the numbers exactly as they are, not just 16 or 16.0, because that way our decimals won't be as precise or accurate. So 53.5 divided by 16.00. Not as big of a decimal this time, but we still do need to do a little bit of rounding. So our least number of sig figs, we have 4 here and 3 here, so we want to write our answer as 3 significant figures. So we'll write that as 3.34. Now the next thing you want to do is divide each of these numbers by the smallest number there is. So if we take a look at our numbers, we have 4.028, 8.06, and 3.34. So 3.34 is our smallest number. So we're going to divide all three of these numbers by 3.34. So here, obviously, 3.34 divided by 3.34 is 1. And then if we divide 8.06 by 3.34, we get a nice long decimal again, so 2.41. And then 4.028 divided by 3.34, we'd write that as 1.21. So this next step, unfortunately, is the trickiest in determining an empirical formula. However, it's really not that hard. Simply what we're going to do is we need to find a number that we can multiply each of these numbers by so that each number becomes a whole number. So let's try 1. If we multiplied each number by 1, we'd still have some decimals. What if we multiplied each number by 4? 2.41 times 4 gives us only 9.64, and 1.21 times 4 only gives us 4.84. So basically we need to keep playing around with numbers to find a number that will multiply each of these numbers into a whole number. So let's try 5. 1.21 times 5 gives us 6.05, so just about 6. 2.41 times 5 gives us 12.05, so about 12. And 1 times 5 gives us 5. So now we have our numbers as whole numbers. So what these three numbers right here are telling us is this is how many of each element we have. So we have 6 carbons, 12 hydrogens, and 5 oxygens. So now all we need to do is write this as a formula. C6 to represent that we have 6 carbons, H12 to represent that we have 12 hydrogens, and O5 to represent that we have 5 oxygens. So from this data right here, we were able to determine that the empirical formula of these three elements and their data, that the empirical formula is C6H12O5. And that's how you solve.